Okay, this is the third and final video, so hopefully you're caught up by now. Now, the entirety of the last two videos was just dedicated to converting the equation into an equation that we can graph. And now, we can graph it, which is the next step. So let me just give an example. Let's do 3x plus 2 squared, because it's always got to be squared, minus 3. Okay, now how do we graph this thing? Well, sure as heck give a really good approximation, and then as we go on, we can find out more and more how it's supposed to go. So first things first, the minus 3 on the outside, that's just down 3. Negative 3 is down 3, so 1, 2, 3. So you go down 3, and then plus 2. Now, you knew this last time, which was very good, that the plus 2 actually means that it's going to the left, not the right. If it's a negative, then it goes to the right. If it's if it's positive, it goes to the left, which is kind of backwards, but that's just how it is. Boom, boom. So you go down 3, left 2. There you go. That's your vertex. That is, the vertex, which in this case, the coordinates would be -2, -3. So that is where our graph starts. That's, where it starts, and that's the vertex. So vertex, handwriting. There you go. Next, we can find out, some interesting stuff from here. Remember, the bigger the number, the wider it gets. Or no, sorry, geez Louise. The bigger this number in front of the thing that's being multiplied, the thinner it gets. So the bigger it gets, the thinner it gets. Think about this is how tall the thing is, This is how tall it is, or skinny at this point. So if it's really tall, it's probably really skinny. So it's really tall and really skinny, It gets tall super fast. If it's a small number, such as a decimal or, anything lower than a 1, then it'll become fat and bloated. Think of it like super short people, Super short people are usually pretty big. Yeah, that's a good analogy if you can think about it. So in this case, it'll be thinner than usual. So it'll go up pretty quickly compared to how quadratic. Yeah?
You gotta come to an end.
What?
You gotta come to an end.
Mom, I'm busy. I'm almost done. Okay. And this is how your graph looks approximately. Now, a couple ways that we can increase its accuracy on how it looks.
We're doing happy birthday.
Could you hold it off for a second?
Yeah.
Okay, it'll just be 5 minutes. Okay, we gotta hurry. So the x, the way to make this graph more accurate is by finding the y and x intercepts. Now x intercept. That's not spelled very well, but whatever. The x-intercept is found, so that's just finding wherever on the x it hits, wherever on this x-axis the graph hits. So the peculiar thing is it's actually going to be hitting in 2 different places, which is what most quadratic formulas do. So you can see how this graph hits the x place in 2 places. And I'll show you why. It's a bit confusing, but I'll show you why. Now, the whole way of finding the x-intercept, if you're hitting the x line, what is the value of y? Always. No matter where you hit on the x in the x-axis, you're always having a y of 0, So then, what you do for this equation is that you equal y to 0. So 0 equals 3x plus 2 minus 3. Now, by now, I hope that you know how to algebraically move things around in an equation. Hopefully.
No, it's not.
So first thing, you plus 3, you plus 3. So then it turns into 3 equals 3x plus 2 squared. So I forgot about the squared earlier. And then you divide this 3. Divide this 3. So what's 3 divided by 3? Ba-duh. It's 1. 1 equals x plus 2 squared. Now, what the heck is, how the heck do we get rid of this squared part? What's the opposite of squared? Square root. This funky looking thing on your calculator. So you square root both sides. This cancels along with the square root. And then this turns into that. Now then, what times itself equals 1? And that's how you find the square root of 1. It's 1. 1 times 1 just equals 1. The square root of 1 is just 1. So that's something that you should know. But if you don't know it, that's fine as well. You can just put square root of 1 and then go from there. So, all right. Unfortunately, we got to the very confusing part. The very confusing part. The part that a lot of people do not like whatsoever. And that is, I hate this part. I hate this part too. It confuses me a lot as well. So, whenever you square root anything, when you take the square root of anything, it could be plus or minus, which is strange to think about. So the square root of 1 is plus or minus 1, which means that it could be positive or negative 1, I think I did something wrong. Plus 3 divided by 3, square root of 1 is 1, plus or minus 1 minus 2. Oh, no, never mind, I'm all right. Plus or minus 1, and then equals x plus 2, and then you subtract the 2 from both sides, plus or minus 1 minus 2. Now, from here, you find out, because this is how a quadratic formula has 2 places it hits the x line, because it could be plus or minus whatever you square root. And usually teachers like it if you put plus or minus this into here. Now, this could work. You could just put this as your answer, or you can do them, you can actually show what they would be, which would be better because you're trying to find the x-intercept. You're trying to make this graph more accurate. So then, you split them up between 1 is plus and 1 is minus. So you have a plus 1 minus 2, that just equals negative 1. So on this line, one of the possible options is negative 1, which, hey, that looks like this option, right? Doesn't that work out? And then your other option is if 1 was negative. So negative 1 minus 2, and that turns into negative 3, which doesn't it look like that option? Ain't that funky? So these are your 2 x-intercepts, your negative 1 and your negative 3. Now then, to find something, what in my opinion is easier to find is the y-intercept. And that, or I just, memorize this if you need, but I'm about to erase it. Okay, good on you. We're on to the second to last thing. So, try not to sleep. Now, the y-intercept is wherever on the y thing it hits, wherever it hits the y number, or whenever it hits the y line, the y axis. Now, what do you notice? It's kind of just the reverse, you know, because you know how whenever anything hits the x-axis, y is 0? Whenever anything hits the x-axis, or whenever anything hits the y-axis, x is 0. So to find the y-intercept, you just need to make x equals 0 in this equation. So y equals 3, 0 plus 2 squared minus 3. Now I hope you know your PEMDAS and you can, figure out how to do that. So this turns into 2 squared, because 2 plus 0 is just 2. 0 just doesn't do anything. This turns into 4. 2 squared is 4. So 3 times 4 minus 3. 3 times 4 is just 12. Minus 3 equals, drumroll please, 8. No, I got that wrong. Jeez Louise. I'm tired. I got up pretty damn early today. So your y-intercept is 9. Oh, damn it, they're saying happy birthday. Okay, so that means that whenever y equals 9, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up here is where this graph is eventually going to hit the y-axis. It's eventually going to go all the way up to that. Now then, something you got to realize is that, or actually, I don't know if you went over this, so I'm not going to say it. Now then, and it's the exact same thing if this is negative. You just need to flip it upside down, and hopefully you know how to do all that garbage. What I'm going to teach you is much more difficult than that. Now, we are going to find the domain and the range of this equation. And how you do that, good enough, you don't have to do any math. You just need to look at it. And, you got to imagine, all the possible numbers. So your domain focuses on your x numbers. What are the possible x numbers that this graph has? And then your range equals the y. What possible y numbers can your graph eventually run into? So first, let's look at domain. These go infinitely out, and they keep spreading apart and they keep getting higher and higher. All the x values, every x value has a possibility of hitting. So for the domain, it'd be negative infinity to infinity. And that is just a funky way of saying, there's a possibility of every single x value hitting this. Now then, the range is a bit more trickier, especially on quadratic equations. So you just mind your own business. You're trying to figure out what are the possible things. Mind you, domain and range, they go from least possible x number to most possible x number, or excuse me, to highest possible x number, In this case, it'd be negative infinity to infinity, and we're going to do the same for range. So you could either start at the top y number or the lowest y number. In this case, let's just start with the lowest y number. What is in this equation, what is the smallest y number possible? Now, just to redraw this to make it look prettier, it basically just looks like this. That's just a basic approximation of that graph. It doesn't have to be specific. Now, you see how they continue to go up and to the side here, but there's no way they can get further than this point, which is your vertex. Now, where's your vertex? Oh, we already found it. It's at -2, -3. So the lowest possible y number is -3. So -3 is your lowest possible y number. And then what's the highest possible y number? That is infinity, because it's rising up infinitely. So it could reach any number higher than -3. That's basically what it's saying. Now let's do a quick other example of something that's like 5, 3. That's its vertex, and it's going downwards, you know, negatively. Let me get a drink of water. Jeez Louise. I'm gonna do that cool thing that YouTube videos do, where they say, "Oh, try and solve it on your own," you know. And go ahead, try and like find the domain and range of this looking graph, you know. So I'll give you like 5 seconds. Or pause the video, obviously. Now then, the domain. What possible x numbers will it be hitting? Well, you know, it spreads out infinitely. It's infinitely big. So your x values are infinite, you know? Or all your x values are possible. So, you know, same as the last one, negative infinity to infinity. And then the range, well, like I said, it'd probably be better to start at the lowest possible y number. So let's see, it goes downwards infinitely, right? Just goes down infinitely. So your lowest y value is negative infinity because it goes down so far. It's just infinity at this point. Now, what's your tallest? What's your highest possible y number? Well, it's wherever this is, right? Because it can't go higher than that. That's like the highest y value that it could achieve. And in this case, it'd be 5. So negative infinity to 5. Now, the difference between this range and this range is the fact that, you know, the lowest number is its stopping point. You know, it stops right here as its lowest number and it goes up infinitely. So negative 3 to infinity. But this one, it starts off at its tallest number and then goes down infinitely. So negative infinity to 5. That's basically the difference. Now, you might not run into this, but as a final little thing, just to make sure you are completely like good with domain and range, what happens if you have a sideways looking quadratic function? So like this, let's see. So let's do negative 2, let's go positive 3, goes right here, that's your vertex. It goes sideways infinitely. Oh, ain't that scary? Happy Halloween. So then, this is weird. We haven't really seen equations like this. What's the domain and range, I wonder? Domain. It's all possible x values, remember. Now, again, let's start with our smallest possible x number and go to our highest possible x number. What's our smallest possible x number that this graph has? It's 3. Like, it can't go before 3, you know, it goes that way. So, you know, your lowest possible x value is 3. Then what's your highest? It's infinite because it's going this way infinitely, you know. It's all the positive numbers above 3. Jeez Louise, I gotta end this quickly. I'm so freaking sore. Range. Now, try and figure it out on your own. All the possible y values. This extends infinitely, you know. So your y numbers are infinite. You can reach every single possible y number by this. So negative infinity to infinity. Oh, Jesus Christ. All right, let me know if you have any questions. My throat is sore.